Hello and welcome to this session on financial modelling with me, Mr. McIver, here at the London Central and North West Maths Hub. This is the second in the series of financial modelling videos. If you haven't watched the first one, make sure you do so, as certain shortcuts I explained there will not be covered in this video. Financial modelling. Today I want to look at saving money. The simplest way of saving money is in your piggy bank or other savings box. Imagine you save £1 a week for 1 year. You will save £1 the first week, £1 the second week, the third week, the fourth week, the fifth week, the sixth week, and so on, until after 52 weeks you break open the money box and find you have £52. That's pretty straightforward to understand. Suppose you want to save up a larger sum of money, a deposit for a house, a holiday, a long-term pension or savings plan. Let's say you want to save £100 a month. Well, that works out at £1,200 a year, and you're probably not going to put this money in a piggy bank, maybe your local bank or building society. If you did this, you'll put in £1,200 the first year, £1,200 the second year, £1,200 the third year, the fourth year, and so on, until after 20 years you have the grand total of £24,000 in the bank. Only you wouldn't. You really should have a bit more than that, because banks pay interest on your savings. We're now going to look at how to model that using a spreadsheet. To construct any kind of mathematical model, you need to specify what the assumptions are that you'll be making at the outset. And we're just going to start off with two. The first assumption is we're going to save an annual sum. In reality, you might be doing this every month, but to keep the spreadsheet simpler to start off with, we'll just look at putting in a certain amount once a year. You're also going to assume that the bank pays interest on your savings, and it will pay that probably daily, but we're going to aggregate that and look at how it works out annually. So let's take a look at our modelling spreadsheet. And here is my first attempt at this mathematical model. As you can see, my two modelling assumptions are up here on the right. Annual contribution, £1,000. Annual interest rate, 4%. Now I want to be able to adjust these figures to run different versions of this model, so I'm putting them up here. And now I'm going to have to build these numbers into my spreadsheet. In year one, I haven't got any savings until I put some money in. So I'm bringing forward nothing into my account, and I pay in £1,000. The interest I get paid on my money is going to be the total amount I have in my account plus this rate of 4%. And so the formula I put in is add cells B2 and C2, those two cells on the left, because the amount I've carried forward plus the additional amount is what I get paid interest on. And then I have to multiply this by the interest rate. Notice I put these dollar signs in here because that fixes my cell reference to this box here. Remember, Excel by default works with relative cell references. If I want to fix it to one particular cell, irrespective of where I am on the spreadsheet, I have to put in dollar signs. So I always want to look at this cell over here. I have, rather cleverly, already formatted this cell to recognize this number as a percentage. That's very easy to do. You simply highlight the cell and click on that button there. Set it as a percentage. And now, if I change that number, it will automatically register that as 0.05, and all the calculations will be worked out accordingly. Oh, you can see I've changed my annual interest rate from 4% to 5%, and as you can see, the amount of money I've got at the end of my 20 years is quite a bit more. Notice how much difference quite a small change in the percentage rate can mean 20 years down the line. I go back down to 4%, and we fall from 34,700 to 30,900. It's dropped by nearly £4,000. If you get a really fantastic interest rate, like 10%, wow, £63,000 after 20 years. So, that is your first very simple model for how a savings plan racks up value over time. Let's go back to a more realistic rate of return here. Let's say 4%. Still not bad. You've got over £30,000 in the bank and you've only saved £20,000. But £30,000 in 20 years' time will not buy the same as £30,000 buys now because of inflation, which we've looked at already. We now need to look at a refined model with a refined set of modelling assumptions. We're still saving an annual sum, we still assume the bank pays interest, but we have to take into account the fact that inflation reduces the value of your cash over time. Let's look at a slightly different version of our modelling spreadsheet. This spreadsheet looks quite a bit more complicated than the last one, so we'll go through it bit by bit. My modelling assumptions for the annual contribution and the interest rate have stayed the same as for the last screen. However, I've now added a new modelling assumption, a rate of inflation. So the first few columns of my spreadsheet look the same. I bring some money forward from the previous year, I pay some more in, I earn interest on the whole lot, I have a total for the end of the year, but now I take into account the fact that inflation has pushed prices of everything up on average by 3%. This means that prices have increased by a factor of 1.03. So what I have to do to get the real value of this total compared to what it was worth at the beginning of the year is divide that sum by my inflation multiplier. Oh, as you can see, it's only worth a fraction more than I put in, less than £10 more. I carry this money forward, I pay some more cash in, I earn some interest, total at the end of the year. Now this is where the spreadsheet gets a little bit more complicated. You see, the inflation multiplier here now has to take into account my inflation over 1-2 years. So the formula in here is actually this multiplier up here times that number there as a multiplier. And remember, inflation of 3% means prices have increased by 3%, so that corresponds to a multiple of 1.03, or 1 plus that number there expressed as a decimal. So, all these numbers down here are simply calculated by taking the multiplier for the previous year and multiplying that by the multiplier for the immediate preceding year. It's quite simple here because all my inflation rates are 3%, all my multipliers are there for 1.03, so in fact these numbers here are simply powers of 1.03. But it would be perfectly possible to build in different numbers into your inflation predictions over this 20-year period. And as you see, with interest rates at 4% and inflation at 3%, I actually end up with a total amount of, in real terms, £17,146. Now that sounds wrong. That's actually less than I've put in. Can you see why that's happened? It's because the real value of my contributions has been decreasing over time. I'm only putting in £1,000 a year, but every year £1,000 is worth less than it was the year before. To find out what that £1,000 is worth 20 years down the line, I actually have to divide by 1.8. That's only a little over half what £1,000 was worth back here. So my contributions haven't kept up with inflation. And the fact that my interest rate is a bit better than inflation doesn't make up the difference. Let's look back at our modelling assumptions one last time. We've looked at adjusting the value of our final plan using a rate of inflation. What if we take into account the fact that money drops in value over time and now adjust our payments for inflation? So let's look at our third version of our savings plan model. So here is my final version of my model. Now instead of an annual contribution, I've got an initial annual contribution because my contributions are going to go up over time. My interest rate is still a fixed figure over time. My inflation rate is simply one figure. I'm estimating it will be about 3% a year over time. But I've got this extra figure here. I've suggested that I am always going to increase the rate of my contributions by at least the rate of inflation. So I put in adjusted payments, RPI plus. This is the amount over RPI inflation that I'm going to increase my payments by every year. In this initial model, I've said my payments are simply going to keep pace with inflation. So I'm not adding any extra money in. My first year, I put in £1,000. At the end of that first year, my cumulative inflation multiplier is 1.03. So the amount of money I pay in at the start of my second year is simply whatever I paid in my first year times 1 plus my inflation rate plus my extra percentage I'm adding. So that's just 3% plus 0%. There's my times 1.03. And as you can see, with my payments in going up over time, my inflation adjusted contribution is simply the actual amount I'm putting in divided by the inflation rate up to that point. Well, that's the 31st of December in year 2, and that's the 1st of January in year 3, so you use the number from the previous year as the divisor. And as you can see, at this rate, I'm keeping the real value of my payments to £1,000 a year. I can now total these up and say, well, the real value of my contributions in today's terms is £20,000. And in today's terms, I'll end up with a bit more than £20,000 in the bank. And you can play around with these figures. If I increased my payments by 1% over the rate of inflation, I do quite a lot better. Notice that if my payments keep pace with inflation and my interest rate is the same as inflation, I end up doing nothing more than protecting the value of my £20,000. I end up with exactly the same real value in the bank as I put in over that 20-year period. It does seem a bit daunting, the fact that even when you're saving quite a lot of money, its value seems to keep going down. I'm putting in more and more and more money over time, and I end up with the same as I started off with. For this reason, most people, when they invest over a long period, invest in something called the stock market rather than just a bank or a building society, because on average, that nearly always pays out more, provided you're investing for long enough. And I'm talking generally 20 years or more. So that's it for this session. We've looked at modelling savings plans, and we've looked at a set of different models, culminating in this one, where you save an annual sum, adjusting payments for inflation, assume a fixed rate of interest, and adjusting the real value of your investment for inflation over time. Please try the questions you've been set. I've given you a copy of the spreadsheet in all its different configurations for you to have a play with, and I look forward to talking to you again soon.